Thanks coming our final tutorial. Okay. So this tutorial question is of course on the topic of several things. One is the generalized Hooke's law, and one is for the pressure thin wall versus, but also could be with the combined loadings. So for these days, the very important one is the versus. Okay, so I've got this question for you to get this idea. So actually, this question, I will tell you, this question was last year standard fundamental question. But this question could be different because they will ask you to work on different location. So if you remember, for the cylindrical versus could be with circumferential and also could be longitudinal. So for these things, you should get an idea where the question is asking. Don't just say, hey, I see this graph. No, the graph could be a lot of different because for cylindrical versus was always like these things. So everyone clear? So if the question comes here, please read the question carefully. So this question very simple, but you need to know really carefully because you see from the song, hey, this is quite simple. This is I know from somewhere. Yes, but the question has been changed. Okay, now this is the question. Okay, first one, we can see the little question problem. The gauge storage tank is fabricated by bolting together two half cylindrical thin shells and two hemispherical shell is shown. That means here is one, here's one, and also along the longitudinal also put together. You just use the bolts put together. If the tank is designed to withstand a pressure of 3 megapascal, so determine the required minimum thickness of the cylindrical and hemispherical shells and the minimum required numbers of birds of each hemispherical cap. No question is location. Okay, just highlight for you. You can see this was a pressure of 3 megapascal, and also determine the required minimum thickness of cylindrical hemispherical shells. So we should know the PR over T, PR over 2T. Can you remember? You draw free ball diagram, you can find this answer will be different. And also the required number of birds of each hemispherical cap. So the location. Remember, for this question here, you must find the required minimum number of birds of these things. The tank and of course, the only tank and the 25 millimeter diameter birds are made of materials having a reliable normal stress of 150 megapascals and also 250 megapascals respectively. The tank has an inner diameter of 4 meters. No question I say you should pay attention for the location. You can see the question here. Will you ask to could be work here? Could also work here? Clear? So that's depending on the question, where the question is asking. Check carefully. Okay? Let's follow here, of course, we should know. This is definitely from the word, okay, thin word versus. So we should, because here is cylindrical, of course, should cut these things, cut the locations from the circumferential and also the longitudinal direction. So of course, I mentioned this one in lecture. I will not mention it again. So that's why you can cut at the location and then draw free body diagram and work out the simple way. Only one workout. This is from school level. You should go these things. Okay? So from here, you can get these things very simply. But remember, the key thing is you should verify whether this belong to thin or not. So from the highlight in the yellow parts, that's the way location. You must verify R over T should be no less than 10. Otherwise, the error will be so big. Okay? So that's why I come back to the question itself. So now, of course, we can go to the question. So that means from here, we should know for whether it's a thin word versus or not. So that's why from here, we should get an idea. So there's R over T, okay? Should know less than 10. So remember, later on, we should verify these things. Clear? So name will write down the given parameters. Okay, the P is a 3 megapascal. Okay, the diameter of the tank, okay, is 4 meters, because it will tell you. And of course, diameter of the bird is equal to 25 millimeters. And of course, sigma tank allowable, okay, will be 150 megapascal. And sigma for the bird allowable will equal to 250 megapascal. That's given parameters. So of course, we should draw free ball diagram from different location. So I just ignore here, okay? So you should draw an exam by yourself. So I just use the knowledge here. So sigma 1 will equal to PR over T. So that means should be maxima equal to the sigma alloy tank allowable. Clear? Because this is from the material itself. So then, of course, based on this thing, we can work out that's a 3 megapascal. Megapascal. R is radius. Remember, you must, so this diameter 4 is a 4 meter divided by 2. Okay, divided by thickness. So equal to 150 megapascals. Clear? So I will put something cancel. So that's why we can see work on a T is equal to 0.04 meter. So that means about 40 millimeters. Easy, yeah? Same way, so of course, there's also on the Hemi, okay? So this is something where, and also for the caps for these things. So sigma 2 is this one is on the longitudinal, okay? I say you should draw by yourself on the, so I should write down here. Clear? I will not repeat these things because I say I use the knowledge just work on these things. So now of course sigma T is equal to PR over 2T. So that's equal to sigma, again, this is tank allowable. So of course, based on this one, so the T should be equal to 2 times T1. I'll just put it here, okay. So we'll put it step by step for you. So that means here we say 3 times 10 power 6 Pascal times 4 meter over 2 divided by 2T will be equal to, so 150 times 10 power 6 pascals. So that means T is equal to 0.02. So equal to 20 millimeters. Clear? So then you'll see, yeah, I finished these things. No, not finished, because you must verify, okay, whether result is reasonable or reasonable. So that's why we need verifying. So whether R over T is no less than 10. So this very, very important. If you ignore this part, sorry, you cannot get a full mark. Everyone clear? So because this to be valid, this one is a pre-requested condition. So that means from here, based on this, we can work out. So R over T, so let's mean here 4 meter over 2 divided by 0.04 meter. So that's equal to 50. So greater than 10. So that means valid. Clear? From this way, we also work out R over T is equal to 4 meter divided by 2 over 0.02. So that's equal to 100. Also greater than 10. Also valid. So the calculations of thin wall versus are valid. Then you can put the answers. So T is equal to 40 millimeters for the cylindrical parts, and T equal to 20 millimeter for the hemispherical part. Clear? So you should answer the question. You stop this side, you cannot get a full mark. Okay, you must verify and reply the answer. Clear? Okay, that's reasonable, yeah? Not that hard, yeah? Simply draw the flipboard diagram, work on sigma 1, work on sigma t. Got it? Done. Verify. Get a full mark. Okay? That's simple way. Clear? So that's the first part. For the second part, so question asked to work on the required number of birds. So on where? On hemispherical part. Hemispherical parts on this side. Clear? So you should find a weather. Also have something here. So depend on the question. Everyone clear? Okay, good. That's why we can see kind of second parts. So that's why we can second parts. Because second part are a little different. That's why I draw flipboard diagram this year. Okay. So that's why for semi-clearing parts, that means we can see the draw flipboard diagram for this. So of course, each part they were fixed by birds. Okay. Clear? Put bang, bang, bang together. Okay. So that's why from here we can get any idea of this. So of course, this operation is quite a simple way we can work out, but we should work out each bird, how much of they can sustain. So that's why for this things, I use different color to show you. So that's about for each bird, so you can see the P bird allowable, so the maximum value, okay, should equal to the sigma bird times area. Clear? So of course, based on this one, we can work out. So the sigma allowable, two parts, as well right here. Sigma bird allowable times pi half d bird square. Clear? We can put the values in. So 250 megapascal times pi times half d already tell you already 25 millimeters. So 0.025 meter square. Clear? So you can work all this thing by yourself. So that's roughly 122.72 times 10 power third newtons. You can work out by yourself, okay? It's simple because it's just a simple way for you to take it out. So now, of course, we know, okay, each of them, they can sustain of this thing. But how about of the whole structures? In the whole structures, we can see for the hemispherical, okay, for this part. For this one, this is a core cap, okay, this foot. For this one, so you can see for hemispherical parts, okay, so the total P is equal to PA. Clear? For whole pressure of the head. How much of this one, the P? Because this one is a radius R, the whole thing, how much? The pressure is a pressure per half D tank square. Clear? So then we can work out 3 times 10 power 6 Pascal times pi, okay, times half over 4 meters square. So of course we can work out. This one is something 12 pi. You can work out, okay, times 10 power 6 newtons. So of course the pressure should be equal to how many of the number of the birds times the P bird allowable of this. So maximum of each bird times how many of this should be equal to the pressure. Everyone clear? So then we can work out. So the one from here, there's a 12 pi times 10 power 6, okay, newtons should equal to NS times each of them of 122.72 times 10 power third power newtons. So of course we can get NS is equal to 307.2. Remember, everyone look on the screen. Because this was 307.2 birds, you cannot go to say 3.7. Clear? Because there's another 0.2. You cannot get a 0.2 give to me. No. We must get one more. So that's why this number should be 308 birds. So you put 307. Sorry, you cannot get a mark because it's already broken. Can you get the point? Make sense? Okay. So of course, this is a question. So remember, we put everything here, we work out. We can get this very easily. But remember, I said, the question will ask you to work on different location. Clear? This question also work on the hemispherical part. Maybe they will ask you to work on this location. Clear? So that's why you should read the question carefully. Clear? Make sense? So that's why for these things, the exam question is quite simple, but we should get the idea how can work out. You see, for this question, it's quite simple, yeah? You just get the parts and draw free ball diagram, work out, done, easy. So that's why for here, I didn't draw free ball diagram because you should do this thing by yourself. If this was your exam, you should draw this by yourself to work out. You cannot put a sigma 1, sigma 2. Okay? So we don't know where's sigma 1, but I say because we use these things for you to go this thing. Make sense? I said this question was a last year standard final exam question. If this one show up again this year, can you work out? Can you get a full mark? So that's why you should, yeah, I got these things. I should get a full mark. So everyone, you should get this thing. When you see this thing, you should get it. If I didn't see this question before, I should figure out a little bit later on, okay? So that's why start a question from easiest to you, go to hard question in the end. If you cannot do it, don't worry, you should get a very good mark. Okay, that's why start from easy question. That's very, very important. Don't start from beginning to the end, okay? That's not a smart way. Smarter way is from the easy question after you use a few minutes to quick check which question you are happy to work, which one you don't like, okay? So get the easy question first. For example, hey, if you're happy with this question, do this question first. If you're happy with the composite, do composite. If you're happy with the method section, do that question first. Okay? Not start from beginning to end, okay? Any question about this? Easy, yeah? Okay. So now we see the last question. Last question here, this question, so we had a similar way, yeah, from previous tutorial lectures. There's only put one part and then put the loads there. That's simple way. But because this question a little bit different, because this load is not on the centroid. So that means you have to consider there's some bending. Okay? We read the question first. So the column is built by gluing, okay, the two boards together. Determine the maximum normal stress on the cross section when the eccentric force of a P is a 50 kilonewton is applied. Here the mention is the P is applied here. Remember, this one not in the center of centroid of these things. So that means this one may apply moment. Okay, so that's why from here we should get this idea. We should find where is the centroid or neutral axis of this structure. Okay, so that's why from here we should find the structure of this. For the structure, this structure typically we should find here this structure something like this. We should draw the axis. For example, we put it at the bottom. Okay, let's say it's the direction. This one also on a direction. It's a y direction. If x direction will be on the up, let's say somewhere here. Okay, but you should draw on the right way, okay? Because this one must be vertical. This is x, for example. So that means from here we can get something the similar way. From centroid, this one is z direction. Okay? Okay? This is a neutral axis. So neutral axis, that will be found different way for the neutral axis. But I would say for every part, this part, every part, there's two parts. One is part of this. One is a part of this. So two parts. Okay? That's why we should find the centroid or neutral axis of the parts. So that's quite a simple way for us. If you say, okay, it's 3D, I can't quite sure, you can draw another way. You can draw like this way. Clear? That's simple way. Okay? So you can see the structures here, here, you get everything. Okay? That's why from here we had so many practice of this thing. It's a simple way. Clear? So that's why from here we can also get the parts. So it's somewhere neutral axis. Okay, so this one we can get any point. We can do it easily. Okay, that's why we see we just put on this structure. I can write down the Y bar. Okay, so the Y bar of somewhere. So of course, based on this thing, there's two structure, two boards, two rectangular one. So that's why from here we must get the idea the summation of a Y bar A over summation of all the area. Okay, hope you still remember. I say you cannot know how to work on neutral axis or centroid. You cannot work on the R. Sorry, up 100% you cannot pass the unit. Because the basic skill everywhere do the same way. Okay, so from here we can get this point. So if we start from here is 0 from here because we should immediately find out some relative location. Okay, this is start from here. So of course this is a positive. Then of course all the way with negative. Clear? For the first one is 150. So of course you can see 150 divided by 2. So that's 75 millimeter. Clear? So that means here is a negative 0.075. Remember, this we use meters, okay? Everyone clear? Times the area. Area, of course, we can get the area is a point. Here, 15 times 0.3. Clear? This area. Area like this way. So, plus. This one can further because this one is 250 and also is a 50. Can you see? So that means on here is a 250 plus, I just put it here. So that will be something like here. So 150 plus, so 250 plus 50 divided by 2. Okay, so that means here is 300 millimeters. So that's why from here, we must work out these values. So that's why I see the location. But remember, here is a negative sign. Okay, it's a negative sign here. 0.3 meter times then the other thing quite an easy way because this 150 and a 0.3, I'll say 0.3 times 0.15. Okay, divide. So 0.15 times 0.3 plus 0.3 times 0.15. Okay, you can work out. So negative 0.1875 meter. So I believe we did some kind of structure before. Okay, so from here we can see that will be roughly, okay, so 0.1875 meter. Okay, so we can get it. So of course we still should work on the I because the structure. So I remember this IC plus AD square because of parallel axis. So any structures here, you can see this structure. So this one is a B, this is a H. Okay, this is X, this is Y. So then of course you can see Rx is equal to 1 over 12 BH cubic. So please don't forget this thing, it's a basic thing. So of course from here, we can work on IZ direction, neutral axis is equal to, so summation of all the IC plus AD square. Okay, you can work out. Y is bottom, Y is up 1. So 1 over 12 times the IC, of course, is 0.3 plus, times height cubic plus the location, the distance, the area, 0.3 times 0.15 times the distance. Here, the distance is halfway of this. Okay, we work here. So that's why from here, we get is a 0.1875, 18.75 minus 0.15 divided by 2. Okay, so that's the point. I put rather for you. 0.15 divided by 2 square. And plus another one, the top one. Okay, also IC. So B is a 0.15, H 0.3 cubic plus area times the distance. Again, the distance we should mention to you, I say is here. Okay, that means here is a 0.3 minus 0.1875 square. So I will not repeat it because we will work out here. Okay, then we'll find here is equal to 1.5609 times 10 to negative third power meter per 4. This one, distance, where's negative? This not this distance, because this one, the distance is here. This one is here. We work out. So I believe you need to figure out this thing because this existed knowledge for a long time ago. Okay. So of course, based on this one, you should find the distance. Okay, for these things. Then of course later on we can draw freeball diagram of these things. Because this one is loading, so of course this one will be P here. So that's why we will have a similar way with a loads upwards. Is 1 is F because summation equal to 0. Clear? And also there's a P will be neutral axis will be called bending like this way, clockwise. So that's why please there's another one will be like this way. It's a moment. Okay? So that's why here is a C, point C here. So that's why from here we can get this idea. So this one summation, we can say summation of all the fx. So that means f over p, f minus p will equal to 0. So of course the f equal to p is equal to 5, how much? 50 kilonewton. Summation of all the m about z will be equal to 0. Remember this for z direction. Okay, so that's what for about z direction for this. So then of course based on this one, so m minus, because m is counterclockwise, so p will plot 1 clockwise. Okay, so 50 kilonewton times the arm. The arm is here. You see, from here, how much will be this one? The total thing is 150 plus 250. So plus 50. So that means 400. Okay. So of course, this one you cannot count because only with the distance from here. So that means 150 plus 250. Everyone clear? So rather 250 plus 150 is 400. Okay. So but remember the whole thing should minus the neutral axis. So that's why here we can work out is a 0.4 minus 0.1875. So it's a meter equal to 0. So we can work on m is equal to 10.6256 kilonewton meter. So that's why from here we can get this idea, we can work out. So that's for m. So remember, we can only get all the internal force. Could be have a normal stress in compression, and also there's a one moment for this structure. So of course, based on this one, we can get this kind of a loading force. So of course, we can see the loading force sigma is equal to F over A. So this is P over A. So then, of course, compression is negative 50 kilonewton. Area, of course, we didn't mention to you the whole area. That's we say 0.15 times 0.3 plus 0.3 times 0.15. So that's 2 area. So that's why we can see as a negative 0.556 megapascal. Remember this one in compression. Okay. Remember this one thing, because of bend moment, they will still apply the one load as we did before. So that's why from here, there's a loading. We apply the loading of this sigma my over r. Okay. So from here, we still can work on these things. for the loading, you see like this way. This one something like this. Okay, so that's why from here we can see the farthest way. Where's farthest way? So farthest way, of course, on here. So that's why will be somewhere on the top surface. Okay, that's why from here we can work on the sigma max. So MC over R. So M we work out before is 10.6256 kilonewton meter times the farthest way, of course, which is relative to these things, is 150, 200, and also the 50. So farthest way is here. So that's why we can see is a 0.45 minus 0.8075. Okay, divided by the I will just work out 1.56, 29 times 10 to negative third meter power 4. So you can see from here is 1.787 megapascal. This one also in compression. Okay, on the top here. Clear? Because that's farther. This one is the intention. So that's the farthest way here. So remember, so that means the maximum normal stress over here, the maximum normal stress will be on the farthest way here somewhere. So the one from here, we can get the maximum stress. Okay, 8.A. We just say the point A is here. Okay, or here. Okay, so that's what from here, farthest way. So that's what for you to get it. So that's what from here we can work out. Okay, sigma A is equal to sigma plus sigma max. So of course we can see that's a 0.56. Remember, it's a negative. And also bottom one should also negative. Okay, 1.788 megapascal. Okay, remember this also, I put this one for you to realize. Clear? To compression. Then, of course, you can see negative 2.343 megapascal. But remember, this one in compression. If you go to the bottom one, you can work out. This one is the intention. So that's why will be negative plus positive value will become less. That's all for this part. That's why you can see from this way. You can see for this question, you will combine all the things together. You can combine how many? Combine the parallel axis, work on the I, work on the neutral axis, work on free body diagram, work on the fracture equation, and put it all together. So that's why these things looks hard, but actually already practiced before, but just use a different way to work out. Okay, that's all for this part for you to get this idea. So we need real practice to understand, not just I come to lecture to practice, or I come to exam to practice something. No, you must do everything behind. So you should after class, you get it practice, get it more, not just read. You should do it. Okay, you're ready to do it. You finish everything. If you just okay, sorry, I stuck here. That's something wrong. Okay, maybe you're not quite sure how it can work out. Especially work on I, work on the dimensions. The dimensions is a school level. Okay, that's nothing for complicated. Just work on the distance by yourself easily. Okay, that's why for these things it's good for you to practice. And the more you practice, you get more skill for calculations. So there's nothing we can do. You must get a practice. Okay, And also I provide a lot of practical problems, and also provide one sample paper for final exam. Please practice, okay? You will get skills. Not just say, hey, can you tell me, there's one say coming, can you tell me this is for your final exam? I say, I refuse to answer the question from the beginning. Okay, because once they come to me, so yesterday, can you let me listen for exam? No, I say, sorry, I cannot answer this question. Okay, so you do the question. I cannot link any question to you, but I tell you, practice, you'll get a benefit. That's all for this. Okay, thank you very much. So hopefully you get some skills and need practice. We still have time for your exams. Okay, thank you very much.